In the last assignment, we talked about having a random variable, x, the probability distribution of x, the expectation of x, or its long-run average, and the variance of x, which is, on average, what's the dispersion of x? How much can we expect x deviates from its average? For example, we had the number of people who enter a retail store each hour. If that's x, the expectation of x would tell you, on average, how many people would you expect to come into the retail store? And then the variance of x would tell you, on average, how much dispersion does that variable have? This assignment, I want to talk about estimators. Suppose we're still thinking about a random variable x, like how many people come into a retail store in an hour. But this time, we don't know the expectation of x. We don't know the variance of x. We're trying to estimate those values. And in particular, how we do that is called an estimator. The possible outcomes are unknown. The probabilities those occur are unknown. And what we do have is we have a sample of x. Let's say we see for the first hour in the store, there are 0 people who come in. Then there's 2 people. Then there's 1 person. And then there's 3 people. And that's our sample. And we want to use this sample to estimate these 2 values, the expectation of our random variable and its variance. First, I'll talk about the estimator for the expectation of x. And the best estimator that we want to use for the expectation of x is, of course, the sample mean. It's the sample mean. And that's intuitive because we know that the expectation of x is the long-run average. So it should make sense that the sample average is a good estimator. In this case, for this sample, the sample mean, the sample average, is equal to, if the sample is size n, 1 over n times the sum of xi. And here, we used x underscore I in the last assignment to talk about the possible outcomes for x. Now we're switching notation. So x underscore I is no longer going to refer to the possible outcomes of x. It's always going to refer to the ith observation of the sample for the variable x. So you add up the sample, and then you divide by n. Here, we're adding 0 to 2 to 1 to 3, so that's 3 plus 3, which is 6. And divide by the total sample size. There are 4 values here. So n is 4, and that simplifies to 1.5. Our best guess for the expectation of the random variable x is 1.5. So now let's talk about, say, number 2. What is the estimator? So remember that the variance of x, the formula for that, is it's the expectation of x minus the expectation of x. We want to square it inside the expectation here. So you take how much is x expected to deviate long-run average, square that so that we don't get negative deviances, and then take the expectations. On average, how much is x deviating from its average? That's the variance. Then the estimator for the variance of x, it's going to look really similar to this formula. Instead of expectation, we have 1 over n, sum I, and then instead of x minus expectation x, we have xi, which is the I observation in the sample, minus x bar. That's the sample mean. And then we'll square it. This is not quite the formula. There's one more adjustment I need to make, and that is because we're using x bar, the sample mean, instead of the true expectation of the random variable. We need to make one adjustment, which is we say n minus 1 instead of just 1 over n. So it'll be 1 over n minus 1, sum I, xi minus x bar squared. Why do we need to make this adjustment? Because x bar is always going to be in the middle of the sample. So the 11 minus x bar squared is going to be a little too small compared to if we actually had information about the expectation of x, and if we could use that instead. If we could use this instead, then we could say 1 over n But because we have to use the middle of the sample, this value is going to be a little too small, so we have to adjust it by dividing by something slightly smaller, making this whole thing a little larger. So that is the estimator for the variance of x, and let's take our sample to find out what that is. So maybe I'll just zoom out a little bit here to do this calculation. Variance of x, and what I'm going to do is I'm going to just put a big hat over the variance of x to say, and the hat means it's an estimate. It's an estimate of that value using a sample. So our estimate of the variance of x is going to be 1 over n is 4, so n minus 1 is 3. And then we add up all of the xi's, subtract them by the x bar, which is 1.5, and then square it. So 0 minus 1.5 is negative 1.5, and we'll square that, plus 2 minus 1.5 is 0.5, square that, plus 1 minus 1.5 is negative 0.5, square it, plus 3 minus 1.5 is 1.5, square that. That's our estimate for the variance of x.